For this problem, we're going to be using x squared minus sum x plus product equals 0. The key for this problem is to get it in the right form, get it equal to 0, bring the 8x over here, and bring the negative 3 over by changing the signs. So now we're good getting it equal to 0, but it has to be a 1 in front of the x squared. So we're going to divide each term by 4 now. So if we need to find out what the sum is opposite of the number in front of the x. So the sum for this one is going to be a positive 2. Now for the product, it's just that value all by itself there, the 3/4. So I can't emphasize enough how important this x squared minus sum x plus product equals 0 thing is. It has a lot of potential to make your life simple and easy. For this problem right here, they're giving you the roots, negative 3 minus 5i and negative 3 plus 5i. I could have not given you this. And you should remember that conjugates always travel in pairs. Remember, I could have. But since we have these, we can find out what the sum is. If you're not comfortable with doing it in your, just adding them up, you should see that when you add these two things up, you get negative 3 plus negative 3, you get negative 6. Negative 5i, positive 5i, they drop out. When it comes time for doing the product, you could use your calculator. I can't stop you from doing that. It would have been done like this. Just make sure you're entering the right things in. The interesting thing happens when conjugates get together is we lose i's. We also discussed about this a trick when you multiply conjugates. There's a little aside. That when you multiply conjugates, the i's will always drop out. You end up getting negative 3 squared plus positive 5 squared. 9 plus 25. I have no problem with you using your graphing calculator to get the values. So for this problem, we're just going to plug in the values. X squared minus subtract negative 6x plus 34 equals 0. The key thing here has to be equal to 0. And we change the sign of it. Okay. Next question. When it says describe the roots, you automatically have to be thinking about the discriminant. For this right here, we have to get it in a proper form. For x squared, oh it is, I take that back. We're already in the right form. It's equal to 0. When it's equal to 0, then we can actually find the a, the b, the c, and plug it in. A is equal to 4, b is equal to 11, and c is equal to negative 3. So when we plug the values into this, we get 11 squared minus 4 times negative 3. Using your calculator is not a sign of weakness. And we get 169. Now, 169, we have to take a look at our 4 cases here. By the way, the 4 cases were, 2 of them were if it was greater than 0, 1 of them was if it was equal to 0, and the other one was less than 0. If it's less than 0, that meant it was imaginary. Everybody else here is going to be real. But the key thing to remember when it was equal to 0, that the roots were equal. The 2 cases for greater than 0 were one was a perfect square, the other one was not. When we took the square root of a perfect square, we got a nice neat number. Now, the question is 169 a perfect square? If you're not sure, take the square root of it. And it is. So it's a perfect square. When it was greater than 0 and perfect square, that meant that the roots were rational and unequal. So it was real, rational, and unequal. It was choice 1. By the way, if the value were something like 168 and you entered in your graphing calculator, watch what happens. If you take the square root of 168, you can see you get a value that is not terminating and not repeating. So you can see that that value is irrational. I'm just saying. Okay, for this problem, when it says solve in simplest a plus bi form, you have to use the quadratic formula. Please don't make me sing the song. But to get it in use the quadratic form, you have to get it in the proper form. Has to be set equal to 0. And now we're good. So for this, we're going to get x equals positive 6, because it's negative b, negative 6 squared, minus 4 times 2 times 7, all over 2 times a. In this case, it's going to be 2. Please use your calculator. When you do this, careless mistakes are made quite often. Take negative 6 and square it, minus 4 times 2 times 7. You get negative 20. All over 4. First step in dealing with a negative sign is to rip out the I. So it could be 6 plus or minus I square root of 20. All over 4. Find the biggest perfect square that goes into 20, and it's going to be 4. So it's 4 times 5. You end up getting 6 plus or minus 2i square root of 5 all over 4. Got to go a little bit further with this one. What number goes into both 6, 2, and 4? That square root has nothing to do with our consideration. Between 6, 2, and 4, 2 goes into it. So it's going to be 3 plus or minus 1i square root of 5 all over 2. And that's your answer. That's the end for today.